All right, I think we have it configured correctly in the room and on Zoom now. Welcome to our June Data Science Lab seminar. I'm going to be talking about OMOP generally and a little bit about OMOP specifically at UNC. As we'll talk quite a bit more about, OMOP is really now the most dominant common data model, especially in federal level research and lots of data sharing collaboratives, but increasingly at single site institution informatics and EHR focused research as well. So this was, let's see, so now the slides are not advancing in the room, it would seem. So it looks like you must have two open now. You do, but I think, well, we'll try. I might have two presentations there, so I have to advance separately. So this was my attempt to have a splashy intro slide, or I should say, this is what Microsoft Copilot gave me, is a splashy intro OMOP slide, which is, I don't know, that's not too bad. I feel like I was lucky to get the OMOP on the database at all, but anyway, so consider yourself splashy intro to OMOP, doing amazing things. Okay, and now the slides seem to be advancing. So I do think it's important to understand a bit of the history of OMOP. OMOP has sort of been different things over the course of its history. So the first piece is OMOP stands for Observational Medical Outcomes Partnership. Before OMOP was a data model, it was actually a public-private partnership between the foundation of the NIH and the FDA and the pharmaceutical industry at large. And it was really mainly focused on pharmacoepidemiology and drug surveillance. And without being a perfect expert on the history, I would describe it as really focused on a public-private partnership to really better understand how to bring non-claims data and non-traditional drug surveillance data into the work of pharmacoepi and drug surveillance. And there were some really big overarching goals of the OMOP public-private partnership. A lot of it was really around develop of common things. So common informatics standards, that's where we have a common data model, but also informatics tools, informatics approaches, methods. There was a pretty large amount of just kind of methods research that was piloted and kind of started to be developed through the public-private partnership. And sort of also generally trying to build a community of people kind of doing this work and developing expertise across these data sources between both public academia and the private sector. So my also somewhat limited understanding, just based off of the history of OMOP, is 2013 came and it was sort of mission accomplished, was declared, and they kind of moved on from there. And at least at that point, this sort of, you know, not enormous scale public-private partnership was sort of, I won't say disbanded, but kind of altered. So then in 2014, you know, after this public-private partnership was kind of dissolved, OMOP kind of rebrands and reforms into the version that it exists as today. So the actual group, OMOP, becomes something called Odyssey, the Observational Health Data Sciences and Informatics organization. That started as a national group. It's really now an international open source group of people that work on all of the various aspects of OMOP, both from a technical perspective as well as from a governance perspective, to really shape and control and develop all the various aspects of the data model and the associated parts for everyone that use it really internationally. The thing that can be a little confusing is it's at this point that OMOP really becomes the sort of shorthand for the common data model itself. So 2008 to 2013, OMOP referred to the group. The data model was just the data model. Starting in 2014, the data model was really OMOP. And so now anytime we're talking about OMOP, we're really talking about the data model or the database that the data model describes. Whereas the group and the people that focus on the group and governance and all those kinds of things is Odyssey. The other thing that has sort of happened between 2013, 2014, and today is that, I mean, saying that there's a common data model war is probably too strong of a statement, but there is some amount of activity between things like CORENET, the Patient-Centered Outcomes Research Group Common Data Model, which, as far as I know, is really both governed and developed by PCORI or groups within PCORI. And OMOP, there's a lot of churn between these and maybe one or two other smaller common data models, like ACT, the Clinical Trials Accrual Network data model, for maybe what is going to be the dominant data model. But over the course of this time, OMOP has just clearly moved into not just, I would say, the primary role, but like a pretty distant leading primary role. It's really, at this point, increasingly just the common standard clinical model for data, both at single sites and certainly across multi-site harmonized networks. And we're really at a point now where OMOP is just, it's actually a requirement to participate in a lot of work. So if you look at really large, especially federally funded and organized multi-site networks, so things like the National COVID Cohort Collaborative, you know, lots of spin-off clinical projects associated from that. The CLAD project associated with all of us, increasingly really just basic participation in these kind of require having your data in OMOP. So this is where I think OMOP is not going away. OMOP is dominant, has become more dominant. And I think really looking to the future, we're only going to be probably doing more and more work with OMOP, both across sites and networks, as well as at single sites. And it's worth probably just going into a little bit more detail on the Odyssey group itself. So it is, as I described, this open international group. Big parts of it are really focused on actual technical design, development, as well as kind of best practices and utilization of OMOP. Another really big part is governance. So they really produce a lot of documentation and support and training on what they would consider the best practices of, you know, all the aspects of OMOP. So converting your data, recommendations for mapping and ETL practices, as well as, you know, I would describe them as fairly active even in recommendations on research best practices. So there's both more of like an informatics side as well as, you know, an observational research side, which can have pluses and minuses. They're also, the Odyssey group is also somewhat active in actually building tools that are intended to work on OMOP data. Some of these are sort of like standalone tools that have a GUI. I'd say the majority are actually R packages that have been sort of shaped by them and collaborators in Odyssey, you know, to do things, to do observational research on OMOP data in a sort of OMOP best practice way or an Odyssey best practice way. The other big thing that Odyssey is really very engaged with, and that is a pretty huge undertaking, is control, development, maintenance, and governance of the OMOP vocabulary. OMOP has its own really significant vocabulary. We'll talk about this in more detail later on, but you know, the OMOP vocabulary is really an attempt to map sort of all major existing other terminologies. So ICD, both levels of HCPCS, LOINC, RX norm, ATC, NDC, all of these things onto one standard terminology. And that is a gigantic undertaking. It requires not just incremental, but fairly active and ongoing work over time. And so that's another really big piece that the Odyssey group is involved in. So my understanding is that at least in America, the quote unquote leadership of Odyssey and of OMOP at large would really be considered at Columbia and then also at Janssen. The people that you see really leading the organization of Odyssey are a group of people that are in faculty and staff positions at Columbia, and then some of those people extend over to Janssen. There are now a lot of organizations that I would say are pretty active in OMOP. So even if you look at something like IQVIA appears to sell a lot of services routed towards OMOP and utilization of OMOP. But same thing with lots of other pharmaceutical companies and private companies. But my understanding is that the sort of quote unquote true leadership is centered between Columbia University and Janssen. Although there are many other active collaborators really across the entire world. I'll show you a map of that. But basically the places where you think of a lot of really active healthcare research and observational research happening are the places you see a lot of OMOP collaborators, the US and Western Europe. And you can go out to odyssey.org. This is their webpage. They have, really mountains of information available there. You can review. And so I guess now it's worthwhile to maybe preface this transition to just saying, like, now I transition into more giving you, I would say, my somewhat directed rationale of like, why should you care about OMOP and why should you feel motivated to learn enough about OMOP to engage with it? And maybe even why should you consider engaging with OMOP over other data models or sort of data platforms that you might be more familiar with using? So the first reason I'll give you is that OMOP is really everywhere. So as I alluded to, or as I openly stated, if you think of these common data models as sort of being engaged in this battle to be the dominant, OMOP is just far and away the leader in this space. So this is a map of active Odyssey collaboration as of the end of 2023. You can see there is a lot of activity in the United States and in Western Europe, but really a pretty large amount of collaboration on OMOP, even outside of places you think of as sort of traditional areas of significant collaboration in this space. So there's a lot in Asia, particularly there are very active groups in Japan and South Korea. I was surprised. I'm not familiar with any groups in India, but obviously there are many collaborators on this map in India. More in the Middle East than I expected. Relative to other data platforms, I'd say more in South America and in Africa than you see in other places. And so this is really, as researchers are engaging in observational healthcare research, particularly internationally, OMOP is really, I would say, becoming an increasingly standardized platform for networking data, not just across sites, but across countries and across entire, nationalized data systems. The next piece I'll say is OMOP is really increasingly required. I would say there's sort of a soft requirement and a hard requirement side of this. So, lots of really large scale harmonized data networks are really just on OMOP at this point. And so to participate, to engage, there's really no getting around. You just have to be facile with OMOP. I'll speak from our side, in addition to all of these active, really large scale federal level networks, we've personally been involved in grants on at least 2 or 3 other really major data sharing networks that are also proposed on OMOP. And we are only one site, right? So, I think at this point, everybody that's pretty engaged with EHR data and data science, OMOP is incredibly forefront at all of the work we're doing, as well as the grants that we're writing. Oh, and I do have, these tips that I put down here. Would, if you plan on engaging with this work in a meaningful or large scale way in the future, really two pieces. So one, you want to know and get comfortable with OMOP. I think the other piece that we've talked about less, but increasingly is a really big way that OMOP is delivered, is through centralized data enclaves. So where, like for us, lots of things we do are on Palantir's Foundry platform funded through the NIH, but increasingly we're, I think at a national level, we're really moving away from these projects where every site gets sort of flat file data locally and you work with that locally and then come back and share results. And increasingly, we're finding data is centralized in a common large scale computing platform. You need to get access to that, bring all of your work to the environment, and do all of your work on the data set in the environment. And often the data model driving those enclaves is in fact OMOP. The second set of reasons I'll give are that OMOP really, I think, empowers both reproducibility and networking of at least of EHR data, but with the option of other data sets like claims data or other types of clinical data, really at a level that we haven't had with other data models or data platforms before. So this is a slide that, I think this is a slide that I stole from Emily Path, that she uses to sort of illustrate what, in a sort of high level way, the actual situation with EHRs across the United States are today. And I recognize this is a heat map. I think this is actually a COVID heat map in the background for something we were doing in N3C or Recover. But so if you focus on the EHR piece of this. So this is supposed to be all of these various sites, probably academic sites across the country, academic medical centers. And, I think depending on your level of engagement with EHRs and EHR data, there's some sense of like, well, lots of sites are now on electronic health records. Isn't that sufficient? Well, no, because obviously, there are different platforms and vendor-based tools for EHRs. So you think about Allscripts versus Cerner versus Epic. But even then, I think as is tried to be represented here by things like green apples versus red apples, simply being on the same platform is not really sufficient to facilitate data sharing between sites. So even if you take something like Duke and UNC as an example, both of our Epic installs are really highly configured to our environments. And that's something that Epic supports. In fact, it's really what a lot of their services are based around, the fact that they can set your EHR up the way that works best for you at your site and your clinicians. And so that's potentially great for your clinical operations, and it's more likely than not really challenging from a research perspective, particularly researching across sites. And so, this is, without a lot of other informatics work and structure, the situation that you're in. Everyone is, technically on EHRs, but sort of either completely different EHR platforms or really very meaningfully different versions of the same EHR platform. So what the common data model can give you, this was sort of my addition to Emily's fruit analogy. Common data model is like your juicer. So it allows you to give some requirements to all of these sites on these different EHRs, simply bring all of it together, juice all of that fruit independent of what type of fruit it is, and just get delicious harmonized EHR data, out from the sites. And so in theory, this is sort of perfect, right? Like all you care about is, again, to extend the metaphor, whether you like it or not, all you care about is the juice from these things. And so by centralizing on a common data model, you're really able to ignore a lot of the differences, both major and minor, between a lot of the EHRs, and really just get to the core of the thing that you're interested in, right? The composite EHR data. And oftentimes this is the case, especially for, I'll say, sophisticated sites that have a lot of informatics experience and EHR data experience. This is what you get. You're able to get really very uniform data out, agnostic of all of these differences. What we have seen, I don't know that I mentioned this later in some of the issues, so I like to talk about this here. One of the things that we do see is not every site is necessarily sophisticated or facile or experienced in this type of process. And so, again, to extend the metaphor, what you have then is maybe their juice is a little pulpier than other places. Maybe they sent you some peel in addition to the fruit. Maybe they have seeds in their juice. And this is all really, I would say, somewhat active areas of research within common data modeling, including OMOP, where, even though you've maybe centralized and harmonized on this common data model, there can still be sites and some decisions that there can still be some aspects of data made in either the conversion process or the underlying data of the sites that can lead to some pretty subtle differences in the data that can require either some redevelopment or post hoc remediation, but at a minimum requires you to be able to identify some of these problems in the end result. But this type of thing is, again, like you can't even really get to this point. Just the ability to share data between a lot of sites on different platforms is incredibly difficult and time consuming without a common data model. It's the type of thing where you spend, say we develop a machine learning model and we would like to test the generalizability of that at another site. Simply the redevelopment of your model pipeline to make it available to someone else's data. I mean, that oftentimes without a common data model between the two of you, that winds up being something like 97% of your work. It's simply the rote work of converting all of your pipelining from one data system to another. Whereas, at this point, we have more experience in piloting, doing things like building machine learning pipelines that are focused on OMOP, and then picking that up and redeploying that between sites on OMOP data. And it just lets you focus on the sort of core interesting machine learning work so much more than the pipelining and the data set level work. So this is what I mean when I get at the reproducibility and the networking between sites. The other reason, and I think this is maybe one of the bigger reasons, is that I don't think I'm alone in having this opinion. I think other people would agree with this, but OMOP is simply easier to use than a lot of other data models, and particularly proprietary data models. So, I have this snapshot of this blog post up from this consulting company. Epic Clarity is not a data warehouse. This is something that I've referred back to. So that's actually from 2012. And this is a blog post that I've referred back to and taught, 50 times between the first time I found this 10 years ago and now. A lot of sites on Epic or on whatever EHR you're on, I think, can tend to rely on using whatever database you get with the EHR as sort of the system that you use to get your research data out of. But these are really inefficient tools and data systems for getting data out, particularly for research. Here they're really focused on operations, like, just running your reports and tuning your operations. They're hard to use for that. They're also really hard to use compared to a specifically oriented research data model. And so OMOP, just presents, orders of magnitude of efficiency in my opinion, and its ease of use. So, I'll talk about this a little more in the upcoming slides, but just for point of comparison, the Epic Clarity data model has something on the order of 20,000 tables in it, whereas the full OMOP is 35 tables, and typically we're really engaging actively with about 6 or 7 of the OMOP tables. So just the amount of knowledge that you have to sort of engage meaningfully with something is much different. And obviously an independent, PI is not the person engaging with Clarity, but just even the time savings that can come from having your data request specifically routed to using the OMOP data model as opposed to using Clarity can be tremendously different. So, I get this question, how is OMOP easier? What is like your specific rationale for this? So as I've alluded to, for one, there's far less data model expertise that's just needed. And I mean, that's important both from like a data design standpoint, as you're designing cohorts or designing the data that you need to be able to extract for your research. It's also important just from, as I was saying, a time-saving perspective. If the code you need to write to extract data is much easier and straightforward, all of that is time savings that can go into extracting data. Another piece that we could probably have healthy debate over, that I think it's more on the side of easier than not, is relying on the OMOP vocabulary. So as I was saying before, OMOP, as opposed to a lot of, I think of it particularly from something like epidemiology, observational research, where you'll really be focused traditionally on a lot of different terminologies for your cohorting and your exposures. So you're thinking maybe about, ICD from your diagnostic perspective for cohorting, or maybe ICD or HCPCS or combination of HCPCS and CPT from your procedural perspective. And then you need to think from potentially a whole variety of different medication terminologies to think about capturing, the specific drug exposures you need. So same thing with lab, you have to be able to engage with LOINC. OMOP really attempts to facilitate all of that by mapping everything onto SNOMED. And so rather than having a lot of different independent bodies of expertise across a bunch of different terminologies, you can get away with potentially just a lot less terminology-specific knowledge using OMOP. You can sort of come and learn the OMOP vocabulary well and engage with that one, as opposed to sort of, knowing multiple different terminologies. And then documentation and support is another really big area. I'll show you some more examples of this, but for many of you that have engaged with the EHR data and working on things that are getting CDWH data or Clarity data, the common question is, well, I don't know what data I need. Can you just give me the data dictionary and I'll pick it? And as probably everyone knows, that's just not possible. It doesn't exist. In OMOP, there are data dictionaries and there is a large amount of documentation. And this is a pretty huge benefit. So even if you're relying on sort of the generalized OMOP documentation, the OMOP general documentation still applies to your specific site level OMOP installs pretty closely. And so it's really the incremental difference sometimes of like, there is no Epic Clarity data dictionary that I can really meaningfully give you versus I can point you to a bunch of OMOP documentation to kind of become acquainted with this. But so let's start to look in more detail. So even just thinking about this again, I feel like most people focus on Epic here, but I mean, I can't reinforce enough, the amount of knowledge and expertise needed to work with the Epic Clarity data model is crazy. So for one thing, I can't even show you the data model because it is proprietary. Additionally, I can't show it to you because it's like 20,000 tables. Like I've never even seen an actual full-scale holistic representation of the Epic Clarity data model. You only ever see very focused, like this is the Resolute professional billing data model. So, I mean, again, if you're a person who engages with the data or need to think about the data and extracting the data, so even from a PI data extraction perspective, I just can't reinforce this enough. Like proprietary data models are typically very complex compared to OMOP. So this is the entire OMOP data model. It is broken into some different domains. That entire standardized vocabulary portion, those are all the tables that just handle the OMOP vocabulary piece. And then there are some other kind of standardized pieces, so from a pharma and a health economics piece, there's the standardized health economics. I mean, really, for the most part, these tables that I have highlighted in red, the person, visit occurrence, condition occurrence, drug exposure, procedure occurrence, measurement observation, I mean, I would say 90+% of the time, almost the entire body of work that we do on an observational study out of OMOP is only utilizing those tables. Maybe also with some, one or two of the concept tables, but that's just the amount of focus and knowledge that you need to have to be able to get your data out is just so much lower here. Again, I don't want to belabor it, but I can't reinforce this enough. It's to me really at a point where, like, if you can get your data out of OMOP as opposed to out of a proprietary data model, like, I would say you want to run, not walk, to like make that data extraction request, as opposed to engaging with the full scale non-OMOP data model. So I also need to talk about the OMOP vocabulary, because this is a major part of OMOP, and it's also, I would say, a pretty sizable rationale for why I think OMOP can be quite a bit easier to work with. So I should also preface this by saying, as I have it on here, I feel like the OMOP vocabulary can be pretty divisive. Like, I don't know people that are sort of lukewarm on it. I feel like there's a tendency more to feel like, yes, it is really helpful and I like to engage with it, or this is really different than how I've always done my research and I do not like it. I'll just put that out there. So as I said before, all the terminologies are mapped to SNOMED. Another piece that's important to know is the OMOP vocabulary is not a terminology specifically, it is an ontology. And so from the pure sort of like information organizational standpoint, the fact that it is an ontology means that there is a lot of data really about the codes and the terminology itself included in the actual data set of the vocabulary. So for instance, this that I have up is really a diagnosis visual example that OMOP itself provides. So if you're more familiar with ICD, you have a sense that in ICD, the individual ICD code is really typically the granular unit that you're working with. And so to move up, to something more general in ICD, it kind of requires knowing a different ICD code, or maybe understanding a little bit about, the 3-digit version of an ICD family versus a 4 or 5-digit. But it basically requires explicit knowledge about the way the codes map to each other. So you can get away, if you understand the ontology of OMOP, knowing a lot less, I'll say specifically, about the individual concepts that the source codes are mapped onto. So here, there's this example of, at the bottom, you have all of these specific types of atrial fibrillation. So these would be the examples of things that are on like individual granular ICD codes, ICD-9 or ICD-10 codes. And there would be some sort of relationship, but not really explicit built-in relationship at the metadata level in the ICD terminology. So here, between the different vocabulary tables, you can actually programmatically do things like say, I don't need, like one specific ICD level version of atrial fibrillation. I need, a descendant of that, right? Like I need the superset of all versions of atrial fibrillation. And so rather than explicitly noting the single code that kind of gives you the family, you can actually programmatically engage with the OMOP vocabulary to pick something that's a descendant. And then you can kind of traverse this really as like a graph. So like programmatically, you can move up and down this graph to pick, depending on what your need is, what you're trying to do, right? So when you're cohorting, You can go very narrow and granular down to single or multiple concepts, or you can traverse the graph to go up to say, like I need every concept that falls into maybe just the atrial fibrillation level. That's a smaller set. And you can keep moving up and up and up to here, the supraventricular arrhythmia superset. So that would include everything below it. And additionally, it'll include a bunch of other concepts that don't fit into the atrial fibrillation, right? So perfect example of heart disease. You can traverse the graph all the way up programmatically to pick these high-level ancestor concepts, and then you can utilize that to really include everything that's a descendant of that. So as you can imagine, picking something that's a descendant of atrial fibrillation is going to have a much smaller and more narrow level focus of concepts versus picking something at the heart disease level. And the key thing is that this is really the way that this sort of graph, knowledge graph network works, not just in diagnoses, but across everything in SNOMED. So if you take something like drug ingredients, I think, do I have an example? Yeah, so I have medication as the next example of this. So a really common just logistical piece that comes up a lot in working with medications and medication exposures is you have some drug ingredient, I don't know, opioid, or here, the example I have is acetaminophen. And you need, like, I need every patient that has had some exposure to this single drug product. But that can be challenging, or at least cumbersome in existing sort of drug-focused terminologies, because if you take something like NDC, or even something like ATC or RX norm, there can be a lot of different pieces and just individual codes that you have to work with. And so then you have to identify all of these codes. You have to put these into, defined groups or in lists that potentially have like hundreds or thousands of different concepts. But within the OMOP vocabulary, again, you can do this traversing the knowledge graph. So here, I just have this example up in the top right-hand portion of the screen where I've written some SQL that basically says, go out to the table that manages all of the drug ingredients, give me back all of the concepts that are listed as a drug ingredient, where the drug ingredient includes acetaminophen, and now utilize that just to give me back all of the specific drugs that contain these things. So you can do this across, as I was saying, all of the SNOMED pieces, but this can be a much easier, tidier way to both contain and handle all of these disparate, really large-scale data pieces that are handled by, as I was saying, hundreds or thousands of codes in a specific terminology. But it also kind of just, in my opinion, cuts down on the amount of explicit knowledge you need. So like if you understand the OMOP vocabulary really well, you can use the same sort of approach across diagnoses or procedures or any of the specific terminology domain areas, right? It's not just you learned this one thing that helps you with medication exposures. The same kind of concept of identifying lower level pieces and then applying that to large scale concepts and groups that applies across all of the aspects of OMOP. And so then I want to move on to go to, I think this is the last sort of body of my rationale of why do I think OMOP is easier to work with. As I was saying before, because there is a huge amount of existing documentation. So Odyssey creates the Book of Odyssey, which is their very large scale physical body of documentation, really largely focused on OMOP. So the data model, how you engage with the data model, best practices, especially aspects on the domains, the different tables in the within the common data model, the composition of those tables and what data is in them. There's some amount of focus on the vocabulary. What I would say is there is a huge amount of just general documentation, even like targeted video trainings that Odyssey has helped produce on the vocabulary. So like all of the different pieces of this usually branch out from the Book of Odyssey to even deeper, more focused resources for all the various kind of focus areas within OMOP. Another piece, our Odyssey is somewhat active in publishing and maintaining GitHub repos, both for OMOP as well as for tools. So, you know, if you go out to Odyssey, there's a combination of things like vocabulary, data model, and sort of ETL tools and things like data schematics, in addition to actual tools. So Atlas is an open source tool that they make available for actually engaging with OMOP data. And in theory, you can actually design and execute analyses against a cohort through Atlas. And then they have a large number, or a relatively large number of R libraries and packages, so Cyclops, Hades, lots of different things focused on different aspects of the observational data process. There's also a pretty active Odyssey community that's international. And I mean, this covers every aspect of sort of community support. So I'm a new user, I'm just trying to figure out how do I engage with, I have a question about, you know, this thing, all the way out to I'm a very sophisticated user, I'm really looking at designing whole new data modules in OMOP, like what has anyone done, what would be best practice in this area. So this is really a pretty commonly used resource for people that are active in Odyssey and working with OMOP as well. Okay, so let me pause as we move on to, are there any downsides to using OMOP? It would not be fair and balanced if I only gave you my reasons for why I think OMOP should be used over other data models. There are some downsides that I can and should talk about. So the first piece is, I think it's simply the perspective that OMOP is, in my opinion, a tool, not a solution. And let me pause there. Because this, I feel like, is a fairly heavy concept. There are some people that I engage with who I would say have the perspective that putting data into OMOP kind of obviates the need for things like understanding your data, or maybe understanding clinical data at all. And these are just completely fallacious perspectives to have. It is crucial, regardless of the data model, whether it's a common data model, whether that common data model is OMOP, you still have to understand the data. The data model is still just a tool, and the tool might be good, the tool might not be good, but it is still just a tool. It does not replace your need to understand the data and to be able to engage with it actively. Case in point, so the process of mapping, converting, harmonizing on OMOP, these are not guaranteed to be 100% successful. So what we have seen, as I was alluding to before with my juice metaphor, is that when you network something like 50, 60, 70, 90, 100 sites, you get a lot of varying heterogeneous results in the data that comes out the other end. Sometimes that is because people have made different decisions or interpretations, either in their underlying data or in their OMOP conversion, that are reasonable and rational. And that is simply an area of difference that kind of needs to be worked out in terms of OMOP governance or harmonization. But sometimes people make really bad decisions. And then you're sort of left with figuring out, how do you fix this? Like, is it possible to whole scale fix someone's EHR data? Or how do you post hoc remediate this? So I will say I personally have a lot of experience with this because we spent a lot of time working with this in N3C. So within N3C, I spent a lot of time looking at data quality in encounters data in the visit occurrence table specifically, and really trying to figure out why we saw things like we have tens of millions of sites, we have sites that cumulatively over the entire network have submitted tens of millions of inpatient stays that are exactly 0 days and seem to have absolutely no data associated with them. They have almost no diagnoses, they have no medications, they have no procedures. They just have tens of millions of 0-day inpatient stays. This is an example of conversion not really happening maybe in the most controlled and predictable way, as one would think. And so a group of us spent months and months investigating this. And what you saw was really this illustration on the left. So I should say, these are figures from a paper that I wrote, I guess, last year, really on our experience in post hoc remediating counter data in the N3C enclave. But what we saw was that sites have really codified their inpatient hospitalization data in hundreds of different ways. And they were extremely heterogeneous ways. So sometimes sites submitted these like consecutive longitudinal, we would call them micro visits. So basically like sub stays that cumulatively add up to longer stays. Sometimes sites just sent like hundreds of 0-day stays that would be consecutive. Sometimes they would send a mix of hundreds of small microservices, micro visits with one overarching longitudinal stay. But the end result, when you tried to histogram this, was what you saw on the right side of the screen. You saw this inpatient length of stay distribution where just disproportionately inpatient stays were erroneously high at the short length of stay portion of the distribution, 0-day, even 1 day. So point just being, OMOP is a tool, it's not a solution. So you can have these types of data, just data quality issues, data conversion issues at various points in the process. And so just because the data is in OMOP does not mean it's clean and perfect and ready to go. There can be rework and even post hoc remediation that's necessary. I probably have to talk about vocabulary here too. So the vocabulary can be really powerful. I mean, I would have to describe OMOP as like, sometimes it feels like it's by healthcare librarians for healthcare librarians. I mean, there are like hundreds, if not thousands of people just focused on the beauty of the OMOP vocabulary and developing it and maintaining it and perfecting it. But it is also really fairly different than the way a lot of us have done observational healthcare research outside of OMOP before. And so, for some people, this is purely a stylistic thing of, I like how I do research now. I don't like the idea of doing research this OMOP way. I don't want to use, SNOMED concepts as my level of granularity as opposed to source. And, so part of this is stylistic. Part of this is not stylistic too. So here, this is the example that I give. So, if you look at something that is very terminology focused, so Charlson Comorbidity Index is an example. These are examples of things that can be fairly difficult to transition into the quote unquote OMOP way of doing things, right? So really all of the papers that we have, creating a validation of a method for the Charlson Comorbidity Index, as well as lots of other methods, they're very terminology focused. And so to lose that terminology, you introduce, just some flat out error potentially that needs to get remediated. So what I found when I was working on building Charlson Comorbidity with others in N3C was that the quote unquote sort of OMOP way of doing things, which is to pick sort of like a high level concept that would be your Charlson group, and then to accept all of the descendant concepts of that gives you a bunch of wrong unintended results. So if you're familiar with Charlson Comorbidity Index, some of the groups that are involved, all of them are supposed to be indicative of basically non-negligible risk of mortality over a period of time. So COPD is one of those groups, and you typically have some very specific ICD codes to identify COPD, whereas the default method of doing this in OMOP, by accepting all of the descendants, you wind up grouping these things like chronic sinusitis, allergic rhinitis, seasonal allergic rhinitis, chronic rhinitis, these things that really are not part of COPD and that don't have the same risk profile as the ICD identified COPD. I mean, over a large cohort, you will wind up adding, hundreds of thousands or millions of people. And so same thing with diabetes without complications. So by accepting descendants, you bring in gestational diabetes. So in dementia, you bring in some things that are more like acute traumatic head injuries. But at the end of the day, the end result is what you see in this histogram on the right. So the blue is what you get when you calculate Charlson Comorbidity Index purely by ICD-10. Orange is what I got when I did it by SNOMED. You can see that you just wind up with something that, for purely kind of vocabulary and syntactical reasons, looks much more comorbid than someone does from a validated ICD-10 method. So, I mean, again, this is, you have to be ready to, I think, be thoughtful and engage with some of these things actively. There are ways to get the wrong answer by just, I would say, blithely engaging with things in the easiest way possible. So another common conversation I have with people about OMOP is, well, OMOP is today a somewhat constrained data model. Like, the stuff that I need isn't in there. This is potentially true. I mean, OMOP is a pretty active area of research. So, all of our sites, all OMOP sites internationally, I would say, are engaged in some amount of updating and extending OMOP out to the various data they need. So in the upper left, here's an example from Paul Nagy's group at Johns Hopkins. They've been a particularly active site. Paul is particularly active in Odyssey at working in OMOP, but also extending OMOP. He was even here fall of last year, maybe, sort of giving a talk in radiology about a lot of this work of looking at extending the OMOP data model out to a lot of imaging concepts. In the lower right is actually a diagram of a project that we're engaged with right now in the data science lab, looking at extending the OMOP common data model out to include additional data that would be needed for looking at a peripheral arterial disease population for vascular surgery. So this is a real thing. OMOP does not necessarily have all of the super specific clinical specialty data that you need for your cohort, but it's an active area that we engage with. So I can't say that this is a showstopper, although it can be a show slower. And so now is the final part. I just want to make you aware of various tools and resources we have for OMOP at UNC. So I would say at UNC specifically, we have three major resources. So we actually have our identified OMOP data warehouse. Or I'll talk about that more in a second. We also have ordered, which is our de-identified OMOP data repository. And we also have OMOP in a pod, which has synthetic data. So our identified OMOP, this is really basically our version of CDWH in OMOP structure. So this is for internal UNC research. This is also what we use for lots of OMOP native like multi-site data networks and data collaboratives that we do on OMOP. And this is what we in track support, and you'd get access to this through the EHR data team. So if it's possible that your data could be done faster and more easily out of OMOP, as you're submitting a data request, you can really talk with whoever is helping you with the data request on whether OMOP is a good option for you. Ordered is our, as opposed to our identified data set, this is totally de-identified. And it's also our pilot of building a secure enclave here at UNC. So we take data from Clarity, it goes to the CoreNet, we get it into OMOP, and then we de-identify it. And then we make that de-identified OMOP data set available in a secured centralized enclave where currently a School of Medicine researcher can request access to. And you would propose a pilot project, and you and if you have team members, your team members would get access. You could then directly interact with this de-identified CDWH data by SQL, by R, or by Python in our environment to do your analysis, to generate your results, and you would do all of that in our virtual secure enclave computing environment. And so just for scale, that ordered data platform currently has 3.1 million longitudinal patients. This is essentially very close to what we have in our identified data repository. It's maybe slightly different, but it's the same order of magnitude. 193 million discrete visits and 1.3 billion lab results, and then also with hundreds of millions of procedures and diagnoses. So we have multiple different pilots that are ongoing in this right now. I am recruiting more over the course of the summer, so if people are affiliated with the School of Medicine and you're interested, feel free to get in touch to talk about ordered. And then the last thing I'll talk about is OMOP in a pod. So this is a purely training and educational environment that I built with Renzi. And so this is purely synthetic data. You get access and you log in, and then you can have access to our synthetic OMOP data, either by Odyssey's Atlas tool, by RStudio, to work with OMOP data that's either Synthea, which is synthetic EHR data, or SynPuff, which is synthetic claims data from the Medicare public utilization file system. But this is intended to really closely mirror Odyssey's OMOP in a box, which is available on AWS. If people have questions or want to take a look at this, feel free to let me know, just in terms of getting more hands-on low-risk access to OMOP data. And with that, let me just stop and see if there are any questions or discussion that anybody has.
Some in the chat. If anybody has any in the room. I see people are raising their hands.
So I'm just trying to find. Okay. Does ordered have full dates? Ordered has dates, but all the dates are date shifted in ordered. So increments of time are maintained. So like if in real life, you have 1 day between visit, you'll have 1 day between visits in ordered, but the dates will be shifted. So we have, we believe that the only type of research that is truly either not possible or really challenging to do out of ordered are things that relied on specific dates. So like air pollution was high on this day, and we need to know exposure to this specific date. That is not possible because of the date shifting ordered. Our records related to children also included in ordered. I don't believe they are. I would have to double check that, but I believe we only have an adult population in ordered. We definitely don't have a sensitive population. So like prisoners are excluded. I want to say children are excluded from ordered too. If I have a second, I can check that. Do researchers combine data from Clarity and OMOP? Yes. Great. It looks like there are actually no other questions. I know we're just a couple minutes over. Are there any other questions that anybody has before we break apart?
Yeah, hello. Can you?
Yeah.
I'm on Zoom. I'm not sure if you can hear me.
We can't hear you. Go ahead.
Okay. So my question basically is just kind of you made and just broadly based on your experience, if you were to be trying to do a research study on the EHR data, how frequently do you think you have to reference back if you were to convert it to OMOP, just to kind of clarify, like in difficult mappings, because I think just basically I was wondering this when you made the comment, like walk, don't run to OMAP from the EHR data. Is that more of a sort of a convenience factor than a you're not going to have to look at the EHR data at all sort of comment, if that makes sense?
I guess just to clarify, is your question more on the lines of like, I have this data in my OMOP data set, but now I want to check it to see if it's correct against the EHR?
Yeah.
Or is it more like, I have my data set, but now I need this other stuff that does not live in OMOP, it only lives in the source EHR?
I'm mostly asking, like, what is the general frequency of having to like go back to the original EHR data? Is the OMOP data generally pretty robust enough to not have to go like check back, or is it, a couple times like a project?
I mean, I would say in terms of like data checking, that is very low frequency.
Okay.
I mean, the fidelity between whatever the source system is, I mean, I'll only speak for UNC's OMOP, because a lot of this is dependent on the conversion. But for UNC's OMOP, the data fidelity between source and OMOP destination is high. And so there's pretty low frequency in terms of like, I see this data point in OMOP. Is that the same thing in Clarity? That is low. What can be more common though is I work in clinical specialty area X, and we document this thing in some data that doesn't come in standard off-the-shelf OMOP. And so it's, all right, so I need to get all of this data from OMOP, but then I need to supplement that with this other thing from the EHR.
Okay. You said that UNC has a particularly good conversion from, I guess, Clarity is Epic's system, or what, however it works out. But
yeah, so Clarity is that's the reporting database associated with Epic.
Cool.
And typically that's the source for a lot of data work that's associated with Epic.
Okay.
Yeah, I mean, yes, I mean, this is somewhat qualitative. I mean, but as a person who has now worked with a lot of different OMOP, destinations, a lot of different OMOP data at a lot of different places, I would say also as a person who is fairly, involved in thinking about what should we be doing with our OMOP, I do think that UNC is a very good, usable OMOP install compared to even some other sites.
That was sort of that got to the heart of my question, which is there a good and a bad way to convert from the EHR to OMOP? And then I guess furthermore, UNC does it well, but other places may not, and under those circumstances, you might have to tweak it potentially.
Correct. Yeah.
Okay.
I mean, just as one example, again, that's top of mind because I spent months looking at it, is some sites, and this sort of gets into the weeds of like how data functions in the American healthcare system. But so if you take something like an inpatient hospitalization, that data is really technically coming from two different systems. You're getting, some data that's facility focused from the hospital, and then you're also getting a lot of professional level data from the individual physicians or licensed independent practitioners that are providing care. But really, all of that ideally should be able to be grouped back together as the care of that hospitalization. Some sites I have seen have instead decided that every single one of those pieces of data should be their own hospitalization. And so within OMOP, they should get their own discrete identifier as being their own unique hospitalization. Like, that is a bad way to load encounter data into OMOP, because that can make a single hospitalization show up as like 20 hospitalizations. That's a bad thing to do. I can say that with confidence, as having worked on remediating that for a long time. But, you know, I mean, I think part of that is just, you know, sometimes inexperience, inability, you know, like lower familiarity either with the data or the conversion process. We do not do that at UNC. And when we work with other sites, I would say I at least try to encourage people not to map things that way.
Okay, so it's generally a process that is reversible and can, yeah, okay, that is exactly what it's asking. Thanks a lot, really appreciate it.
Sure, no problem. Maybe, are there any other final questions? Maybe we would have time for maybe one more question if anybody has a question. All right, hearing none, I will just thank you for your time. If you have questions or interest in talking about OMOP or ordered or any of these resources, feel free to reach out to us. I don't think we have not set our July seminar topic yet. So simply stay tuned for more information to come on our summer seminar topics from the Data Science Lab. All right, thanks everybody.